Better to be forward than backward.
Hello, Warren.
Hello, there's a big color mixing where I'm trying to.
Yes.
Do you want to be someplace in the middle? You can sit on the floor.
I see we're continuing our tradition of meeting in really weird rooms. Although I think the giant column in the middle of the room is maybe a new low.
I think I have to buy
We need
them
better
chocolates
bribes.
next time. Buy Stephanie something good.
Come sit here in a chair. I don't need that.
I don't know if you.
So, hello, welcome to IDR. At least we seem to have a room that's big enough that everyone can sit down who wants to sit down, so that's something. We have a note well. It's the same note well that everybody else has, only it's on a different template. But, you know, and less legible, like says Jared. Thank you. But, you know, despite the fact that we see this so often that everybody's mental filters just filter it directly out, I hope that at some point you have read it and at some point you have noted it well. And if you haven't, you really should.
Okay, John and I will tag team this. We've gone through a couple interesting months. We thank everybody for meeting in an interim before Bangkok so that we could continue the working group business. We have several holding patterns, and I want to sort of let people know that there are holding patterns. There may be chairs on the in the difficult seating to the left, folks, if you want to find some. So we're waiting for 5575 BIS completion, and this BIS was trying to get the current status of the 5575 updated. We have, Christoph called for feedback on implementations, but we really haven't seen that, and I've got several other drafts that are waiting on it. All the flow spec drafts will need to point to this new BIS, as well as two drafts that were pretty much through working group last call, flow spec OID and interfaces set. So I need to have feedback. You can run to the mic or you can tell the chairs privately. We really need to know how long we should hold this in order to get that implementation. We'd like to have 100%. But if you know of a 5575 implementation and can send it into the list, we'd appreciate it. So, question, how long do we wait? I'm going to suggest tax day in the U.S., April 15th. That's always something useful. It's a date that the U.S. people always remember with bated breath. We have the early allocation. We extended 2 allocation pieces recently, but we're coming up on several other allocation. John and I would be thrilled to have implementation and send this to the ISG so we don't have to go through another early allocation, but we welcome sending this again. We just need to know that there's work occurring. Do you have an implementation? Do you have something in progress? That's what we needed for EID distribution. Another question, since we have 2 implementations, is EID distribution ready to go? We sent it through a working group last call, but we didn't get enough responses. So please, if you've got this code base, I will be sending out notes saying, are you ready to do working group last call? Because these early allocation drafts get first bid at working group last calls. Alvaro, other people had general concerns about glowing message size and error handling for BGP LS if it's BGP LS information is impacting the path. You'll find that's part of the 7606 carve out. And there are many small BGP LS drafts to get code points. We've made some good way forward. I'm declaring, and you can come talk to me, that the extended messages draft is passing working group last call. I will send this to the list tonight, but if you have some major problem, come argue with me after the working group where I will send that out. Bruno and all that I've seen, mail that I could read, seems to indicate we've got some changes to the final draft, but we're come to sort of a consensus there. It's rough until we get another round on the draft, so please watch for that. And we find there'll be a presentation on improved 7752 BIS by Catan today. We think that shows good progress in handling the air conditioning. So we think this is a good progress, and we're just going to let all the drafts for the BGPLS in, assuming that implementers can do the right thing with the BGPLS and segment routing. We do propose making it easier for drafts which are going from the IGP, and we've talked to the LSR chairs, and they'll query LSR, so that if you have a code point in OSPF ISI, is that you can just append that draft. Now, that is for simple drafts, and these drafts will be co-reviewed by IDR.
This is basically for the class of drafts where something's been defined in the IGPs, and there's, you know, we can, there's a whole little zoo of IDR drafts that basically say this thing over here in the IGP, we want an encoding in BGPLS also. And, you know, we said this should really just be, you know, in one document, just give us the ISIS encoding, the OSPF encoding, and the BGPLS encoding. There's no need to have a second document for rest.
We think there are more useful things to do with your life than write another draft like that. I see Catan nodding his head and perhaps care. Okay, there are these adoption requests. Please review them. I will begin to cycle those out now that we've made that progress. If you are ready and want to come up and tell me that, then I will start your drafts shortly, given a 1-week hiatus. Most people do not speak to us a week after ITF while they catch up on everything else. So I will start it on the 6th or so of April. So please let me know. There is another adoption request from Heinz, IDR, MSDP, BGP aggregation. And after we do the presentation today, we'll get a sense of how quickly we need to work that. That was from November, but let's see where, we don't have a presentation on that today, do we?
Probably Thursday.
Is it on Thursday or did I? Jacob, do you have a presentation on this time, or did I miss that? Okay, then we'll start the adoption unless you have something you want to say about it. I'll leave that to open time on Thursday in case you want to. We still have some time if you wanted a status update since I haven't started adoption. But my plan is to send it forward to adoption request. Is that good? Okay. Partial implementation reports. This is where we get stuck, and I need some input from the group. We have two implementation, we have a 2 implementation rule, but we have for draft IDR BGP best path selection criteria, we have 2 implementations from Cisco in 2 of their trains, plus a partial from Juniper. Is this enough? Jeff, I believe it was still a partial. Okay. Then if it's enough, please let me know and I'll go forward. I'm intending to do it because this has been sitting there for 6 or so years with these implementations in the field. We have BGP tag implementations, again, with 2 Ciscos. We have rumors of others. We do need some indication from the working group, and tunnel in caps John will cover.
Yeah, so the part of the sticking point on tunnel end caps is that sort of if we had it to go back and do again, I think that maybe what we would do is produce a, the infrastructure piece of it, progress that, and then produce individual or, omnibus, whatever, but a separate document that had different tunneling technology implementations. So as it stands right now, the document has everything in one place. So great, smaller document set. But the problem is that not only does nobody have a full implementation of the whole thing, but it's unreasonable to expect that anybody ever will have an implementation of every single tunnel type that's in that document. So my feeling is that our requirement for implementation on that should be that we sit down, look at the document and say, okay, this stuff is the fundamental stuff, and do we have implementation of that and at least one tunnel type on top of it? And I'd be glad to take feedback, on that strategy either or now or, later, however you like.
John and I really need your feedback on these partial implementation reports because we'd like to clear our deck, but we got to clearing the deck and we found sticking points. So we just need some advice. If we do not receive advice from you, we'll just try to do the right thing and you can complain. Yeah, I still need implementations for these 3 drafts. They sit there in implementation. I did get the implementation status working on the web page, so you note that it's past working group last call. Okay, if I missed yours, it is possible. Send me email, come up and send it so we can cycle through these fairly quickly. We will do working group adoption or last call pretty promptly in 2 weeks. So if it's your turn, be ready, because if you don't get enough response or you get, if you don't resolve the conflicts yourself or ask for help to resolve the conflicts, it will go to the back of the line. So help yourself get through the process. I think we're done.
Okay, sorry, pilot error here. There we go. And,
You can pick. I think if you stand on the pink X,
supposedly the X, yeah. Sorry.
you want to stand close to the X. Yep.
Okay.
Yeah.
Okay. So, hello. This is Adrian from China Telecom. I just want to make some updation for our draft about the BGP expectation for the inter-edge topology tree.
Can everybody hear okay? Can you hold the mic closer to your mouth?
Okay. So there are three parts. The first is I just make a scenario summary for a person that is first to into our the first time to see our draft. The second is the update solution, and this is the scenario summary. In our network we have the following topology graph. We have one backbone and about several hundred main or IDC connected to the backbone, and we want to deploy the only one PC or SDN controller. So we want to do the end-to-end traffic engineering. So first we must to get the underlying topology from a router within the network. But currently the BGPLS can only get the topology information from one domain. So we need find some solution to retrieve the inter-edge topology. So the right graph is just abstract the topology. There are two different IGP domains and connected to each other, and these IGP domain may run different IGP protocol. We want to deploy the BGPLS in only in one router in each domain. So the PC controller need to collect the intra-domain topology and reconstruct the inter-S topology accordingly. There are two scenarios for this solution. The first is the native IP scenario. This is the original solution. For native IP scenario, we just want to redistribute the connect interface as the SBR and carry the original information within the BGPLS prefix NLI. So the controller, after getting this information, the controller can reconstruct the topology between the different AS. The second scenario is for the TE scenario. We propose to add 3 TLV within the BGPLS link NLR for the topology reconstruction. But after considering the some communication complexity of the PCE XTN implementation, we just want to propose one new inter-S BGPLS NLI. The reason to do this is, if we put the information within the original BGPLS NLR, because the two end for the inter-S link located in a different IGP domain, so there is no way to fill the remote node information. Actually the inter-S link just is actually one single end link, and it is similar with the lookback interface. So we think if we can newly define the inter-ST NLR, it is maybe better to implementation and also for the further distinguish between the inter-S link and the intra-domain link. So this is the benefit for the newly defined NLR. So the first is there is no ambiguity for the link NLI, and the second is it is easy to for controller to filter inter-S link. If we use the method that described in the previous draft, we must pass the packet into the link descriptor and then find the inter-S link and the intra-S link. The third benefit is such solution can also be used for native IP scenario. Currently, for native IP scenario, we just use the distribution and different approach to the solution. So if we use the newly defined NLI, we need not do the distribution. We just need to use the passive mode for inter-S link. So the passive mode, passive link also can act as one end link. So based on this solution, we can unify the solution for the TE and the native IP scenario. So this is the updation for the inter-S topology retrieval. So, any comment?
Okay, during question and answer, I'm going to work on getting the next slides up. But please go ahead and come to the mic if you have questions. Thank you.
I am Huaimo from Huawei. Today I'm going to talk about BGP extensions for SR36 segment order allocation. So right now we know for BGP LS, we have a lot of information such as link state information, and those link state information includes TE. So right now, BGP also do the segment routing policy. So when we do that, we also allocate some and manage some resource information. So from this point of view, it's natural and also beneficial to let BGP to allocate and manage SR-V6 segment routing IDs, because these IDs can also be considered as some kind of resource. So here we will consider some extensions to allocate two kinds of IDs. One is for SR-V6 node segment routing ID. Another one is for SR-V6 adjacency IDs. So basically, the extension is based on BGP LS. So for BGP LS, we just collect information from the network. Here we go on another direction. So we allocate ID and then let BGP LS send those IDs to some elements of the network. So here we just introduce a new protocol ID. So when we use this new protocol ID, then the information will go in another direction. So for segment routing V6 ID, so we just using the existing architecture or structure for the SID, for collecting SIDs. So here we just do a little bit of extension. So we will include node ID and location TLV. So those TLV will contain the information for SR-V6 segment routing ID and the related informations. Here, basically, we just contain two TLVs. One TLV will for the segment routing ID for V6. So another one is for locators. So these two information will be enough for the segment routing V6 IDs. So another type of ID is for adjacency. For adjacency IDs. For adjacency IDs, we also use using the same structure from the BGP LS, but here we use a new protocol ID. So this new protocol ID, when we use this new protocol ID, and then the information will go in another direction. So here, for SR-V6 adjacency ID, one is for point-to-point link, another one is for multicast link. So for point-to-point link, the information for these two types of adjacency IDs, the information is almost the same. Only difference is that for multicast adjacency ID, we use another remote side ID. So for the remote side ID, enable route ID, because we have two different protocols. One is for ISS, another one is for OSPF. So because those ID, the length of that ID is different. So for OSPF, we just use 4 bytes. So for ISS, we need 6 bytes. So here we just introduce a new flag called O. O means maybe OSPF. So the ID will be 4 bytes. And then if it's not O, and then there's IIS, it's 6 bytes. So that's the difference. So any questions and for this one?
Hi, Ketan Talawlikar, Cisco. So I'd like to bring out one aspect of this draft, and there is a similar draft for SR-MPLS, which is also for adoption. So until now, all the BGPLS drafts and all the framework that we have had are for reporting information from the router to a consumer or any application like a PC or something like that. These couple of drafts are using BGPLS as a provisioning tool, as a provisioning mechanism. So we're talking about somebody from the top going and allocating SIDs on routers. I think this is a major shift or change in whatever we have had so far in BGPLS. So I have some concerns, and I think we should be very careful where we are taking this.
Ketan, can you list your concerns or send them to the mail list?
Yeah, sure.
Either one works if you wanted to. We have enough time if you wanted to mention them today. Do you want to go?
Robin from Huawei. In fact, when discussed with the customers, so they have this concern about this the scalability of the SRv6, because now that's for the SRv6 the seed maybe need more configuration than the SRMPRs. In fact, the 2 or 3 years ago, we proposed that's a draft. We try to use the BGP link state to allocate the SR label. But here we tried to propose a possible way to distribute it, to allocate this SR seed centrally to release the concern on the scalability. That's here. But I think that's here use the BP link state is simple, is just to introduce the extended TRV like this one. But maybe we think that the BGP will be used widely for the SR implementation. So I think even it's not the BGP link state, maybe we also can utilize the other extensions of the BGP for this the purpose to allocate the SR seed.
AC Lindum, Cisco Systems. How much can I say? That was an amazing stream of consciousness. Anyway, anyway, I was just going to comment that we have, I mean, I don't want to lock anybody into one operational model, but we do have these things in the SR Yang model for both OSPF and ISIS. So that would be one way. It's not like you couldn't do that. I mean, we have MPLS now, but there's also SRv6 as well. The MPLS part is on its way to working group last call. The SRv6 is pretty new for this Yang model, but this is new as well.
Ketan Talaulikar, Cisco. So there are lots of things to be provisioned on routers. I mean, lots and lots of them. The mechanism that we use for that, for SIDs and locators and all, they are fairly more like a provisioning or a configuration stuff. They're not like dynamic things. Like, for example, we have BGP SRD extension with signal SR policies, but they are more dynamic control plane kind of a thing, right? Here it's relatively more stable. It's the initial configuration kind of a thing. So I think the Yang models and other provisioning mechanism that we have is sufficient, and I would really question introducing this into BGPLS.
Yeah. Please go ahead and respond.
Yeah, I think because right now you see BGP already have extension for segment routing policy. So those when we do that one, we also needed to use a resource and also allocate resource, right? So that's those segment routing stuff is also done by BGP, and also the BGP will send those information to the equipment in the network, right? So here, this is just another extension. So just a little bit more extension to do need more things. For example, segment routing ID. So as Robin mentioned that, so you maybe we don't do extension to BGP LS, but we can do general to extension to BGP. So this is another way, because this another way have a lot of benefits. For example, it's more scalable. So we can do that in CLI or whatever Yang model. Yeah, that's another way, of course. But this is just provide another options. This option may have more benefits, and then maybe someone like this one. So just one, because we just propose this one, and then we can have more discussions.
So I have two comments to make, and the first one is kind of me as an individual working group contributor, and it's just because you can do anything with any protocol doesn't mean you should. And the second is more with my working group co-chair hat on, and it is that although we do a lot of SR stuff in this group, and the IGP groups do the same, we do we have a spring working group which is chartered with the segment routing architecture, and it seems to me like a bunch of what we've been talking about just now is more an architectural question than a dynamic routing. How do we arrange the bits on the wire? So I think it would not be a bad idea. Have you presented this or taken this to Spring at all?
No, this is the first time.
Okay, I would suggest that you at least go and talk to the Spring chairs and make them aware of this and ask, if they would like to discuss this in the Spring working group, because it does seem like the architectural part of the discussion is appropriate for Spring. And unless there are any other questions or comments, I think we're ready for the next person. Thank you. That's also you. Okay, perfect.
So this one is about routing policy distribution. So this is already version 4. So this one, I think the first option we already presented last time. Just give us summarize. So for the first option, just we do extension in the action field. So we just introduce a new bit. So this new flag bit will, when this new flag bit R is set, then that means it is for routing policy distribution. So those routing policy is encoded by extension, a little bit of extension to the wide community. So the second option is that we use a new shuffle, and then under that one, we have a new NLRI. So this NLRI, so under this NLRI, we also will use the wide community. So wide community is the same for two options. So for extension to wide community, we just extended a few of TLVs. So right now in wide community, so the already defined TLVs, they have a target TLV and a parameters TLV. So for the target TLV, we define a new route attribute TLV. So this route attribute TLV, in fact, just defines the matching conditions. So for this route attribute TLV, we define 3 new sub TLVs. This 3 sub TLV is one is for IP prefix, another one is AS path. The third one is a community. So for the IP prefix sub TLV, we just define this IP prefix, the matching type, and then IP address, and then mask, and then the grid mask, and then the less mask. So we can have multiple these of items. So this sub TLV will define the matching conditions. So here, for example, for the matching type, we can have exact match, or we can have give a range. We have 4 options. So for example, if we have an exact match, in this case, we just give an IP address and then the mask and then mask length. So in this case, we just match this exact IP prefix. That's the matching condition. So another one example is that we can give a range, mask range. So in this case, the mask type is 3 in here. So we give an IP address, mask length 24, and then the grid mask is also 24, and then the last mask is 32. So in this case, that means that we would like match this IP prefix 18.1/24. So from mask length 24, greater than this one, and less than 32. So we give a mask range. So this is sub TLV just define one type of matching conditions. So we also define for the this for IPv6, the similar the sub-TLV. We also define new sub-TLV called AS pass sub-TLV. So this sub-TLV just gives regular expressions for the matching condition. The third one is for communities. So this one just lists a number of communities. So this gives us the matching condition is that we need to satisfy all these communities. So this is for matching condition. So also, because in the white community, we have high-level TLV called parameters TLV. So on that parameters TLV, we define two new sub-TLVs. These two level sub-TLV is just indicates the operations. So one operation is about the MED operation. So we can, when matching condition is satisfied, and then we can do some operations. So here, for example, for MED, we can have just set the MED to a given value here, and then we can add, and then we can subtract. So this is an operation for the MED. So another one is some kind of a change to AS pass. So we can add a sequence of AS to existing AS pass. So this sequence of AS numbers, we can define by this sub-TLVs. So we can have AS number 1, and then this AS number 1 may be repeated a number of times, and then and so on, and AS number n repeated sometimes. So this gives a general structure to indicate a sequence of AS numbers, and then this sequence of AS numbers, and then attach to the existing AS pass. So that's all. And any comments?
I think previous John's comment applies, but besides the point, where's my feedback loop? So I want to install an entry, and how do I know whether it has been installed? Who's going to tell me that this prefix is actually has been applied and forwarding and working? Yes?
Yeah, that's you mean
No, it's a serious question.
the community draft? The community draft, I think, is adopted, right? You mean this one? This one is depend on the community, wide communities draft. That one is in working group draft for some time. Is Robert?
I don't think that was the question. Do you want to try to restate it a different way?
Yes, so you're configuring things. I want to know my operational state after configuration has been done. So how do I convey my operational state or derived state with BGP?
So you mean you configure on the BGP on the some controller central part, right, for the policy? So this policy will distribute to the edge node or whatever. So you want to verify whether your configuration is in that.
And I want counters. I want everything I usually do with policies.
Yeah, that's maybe there's some ways to do that. For example, you can use CLI to check whether your configuration.
So I use BGP to configure and CLI to retrieve counters.
Yeah, that one means we may have more work, right? We can do more work to detect whether we are stuff there, right?
I have a question for you, Jeff. How does that work with FlowSpec?
Same way you do CLI, right? No, but it's a serious question. And
Yeah, no. Yeah, this one, for example, for the same thing, for example, for BGP policy, our segment policy, and then we distribute to the node, how can we verify our stuff is there as what we expected, right? This one, a similar thing. So we configure some kind of policy, we distribute there, and then what happened in there is what we expected on those equipment. So I think we need to have some work there to really detect what's there.
the only thing you could do in BGP is withdraw prefix, right?
So, by the way, I'd just like to remind people to please state your name when making a comment.
Sorry.
Yeah, that's a very good question. I think also very practical stuff, right? Because you do something, you want to see something.
Yes.
Yeah, that's right.
Christopher Leiber, next layer. Since you asked about FlowSpec, I don't think this is the right vehicle for this.
So there were two options actually, but I don't see any similarities that can be used with flow stack. You have like so many different components in there.
Oh, yeah, I'm
There's
sorry. I didn't intend
basics.
to suggest that flow spec be used for this. I was just trying to say this isn't the first time with BGP that there's, not a return feedback loop.
Yeah, Jayong from Huawei. Actually, I want to mention that also we don't have this feedback for many existing market situations like flow spec, like or we have with the SRT policy, we need some mechanism to give the feedback back to the controller. So I think this is a generic case. For this one, maybe you also need to consider that.
AC Lindum, Cisco Systems. Yeah, I think in response to that, the good thing about as primitive as it is, just applying a policy, you're not one level removed. So when you send a community, you don't know that everybody supports it. Whereas if you do a RESTconf or NetConf, you get an RPC response right back saying whether it was worked or not. You get immediate feedback. But the other thing I'd like to say is operationally, what dynamics, what advantage does this have over just provisioning it using, NetConf or restaurant? What's the advantage?
Yeah, that's a good question. I think in our because this is version 4, I think in the previous presentation, people already take why we need this one. So the reason is that those traffic is dynamic, and then the policy, if it's not done manually, sometimes we need to adjust or re-optimize those paths. So for example, we have statically configure some paths, and then those traffic go through that path. But because traffic is dynamic, and then maybe that path is too crowded, and then we needed to reroute or select another path or so in this case, we can do manually change configuration and then change those traffic. And then here, if we have this one,
right,
we can do some dynamic.
But there are products that do this today with proprietary CLIs for people that monitor traffic and push BGP stuff all over the network and do this already.
Yeah, I know.
I mean, and they could be vastly improved just by using say RESTconf to what they're doing in common models. That would improve them. So I think if you just take those and improve it with RESTconf, you'd have the same advantage with none of the complexity.
Yeah, you mentioned that the existing way because it's through CLI, whatever we can.
Yeah,
I'd like to close the line after Jacob, by the way.
Okay, Robin from Huawei. In fact, we also have ever used as the CLI or the NetConf for such the purpose, but we have faced some challenges. The first, this is the CLI. I think there's the interoperability issue. And the second one is a performance issue. So that is why we think that use the BGP, that is for the purpose. So we think that how it can be standardized, and also that's for the interoperability, and also that is the better performance than the CLI. Okay.
Robin, can I just get a tag on for a clarification from Robin? If he comes back, Robin. Is it due to the multicast feature of the BGP distributions that you find the improvement?
Sorry?
Is it the fact that BGP is one point sender goes to multi-point receivers that provides the scalability that seemed to be in your response? Did I understand that correctly?
I think that's here we have this even for the SR policies distributed, they have the similar the issues, but we think that is already the such solutions.
Yep. Okay. I'll take that as a solid yes, that it's already being, that's what I picked up from Spring. So folks, I think that's what I took out of Robin's comment is there is this one sender to multicast receivers for BGP. That isn't true in many of the NetConf situations, AC, that might be something for the NetConf people to think about, that problem of scaling. And I think that's really what you're hearing a lot of feedback on. Thank you, Robin.
Jacob Heights from Cisco Systems. This tendency to use BGP to send stuff over air, that's fine, and not having the response back. So we have stuff like NetConf to do this or RPC to do this and get the feedback. Now, the reason we use BGP to do some of these things is to go inter-AS, right? Where one AS asks for a flow spec to be installed by another AS, and that AS may or may not accept it, and that's his prerogative to accept it or not accept it. Right? So that's why we use BGP, because we want to send it from one AS to another AS. Right? Is this what's required in this case? I don't believe so.
Yeah, this in this draft, you see, we also mentioned that this apply to the multiple AS, because we want to adjust the traffic from this AS to another AS remotely. That's the trick there. We try to play the trick there.
You want to send this policy from one AS to another AS to have him install the policy, just like FlowSpec.
I think maybe different. Here in our draft, we explain more details how we get from, because you see the policy is locally, and how can we get a traffic changed from the other AS? So I think we have something there.
I think we're on our next presentations.
Yep, thank you.
Okay, can you hear me? Working, right? This is not, is it working? Okay, so I'm going to talk a little bit about.
Can folks hear Linda? Yes? Speak up, put the mic closer.
Oh, okay. Okay, SD-WAN. Okay, so there are several drafts on SD-WAN already. In the RTG working group, we have a problem statement and general gap analysis. In BAS, we have secure EVPN and secure L3 VPN. And so for the SD-WAN, see here I'm talking about some of the different aspects. So SD-WAN here, we have two scenarios. One is like you have a branch office, remote branch office, say in a shopping mall or in cloud data center, where you initiate either a UCP or virtual CP, and you're using the internet to connect to your corporate VPN, so that all the traffic coming to this UCP or virtual CP have to be encrypted and go through any public network. There's another scenario where that like typical enterprise today have a CPE interconnect by the provider VPN. And today they want to be able to utilize some additional bandwidth they also purchase for internet access. So they basically can upgrade their CPE to have extra ports connect to the internet, and they have existing ports connecting to the provider VPN. So for this case, where that traffic going through the existing private network goes through them natively, they don't need to do encryption, because encryption is very expensive. In addition to the key management, the encryption itself is very process intensive. And only the traffic go to the untrusted network need to be encrypted. And the users, it is really the user policy. Some traffic, they have to go through private network. Doesn't matter how congested the private network is. Some traffic can go to either one. If the private network has bandwidth, goes through private network unencrypted natively. if the private network is congested or reaching certain threshold, goes through the public network, but it's very important to be encrypted. So that's for the CPE's perspective. There's also service providers, and today they're interconnecting by private links, private lease lines. And for some transit demand for increasing bandwidth, instead of putting the infrastructure to add the bandwidth, today many of the service providers do want to utilize available public network. So for the PE, they can add a port which can interconnect to the public network with the encryption. So, so if we down to the deep, we have those three cases. So for the first case, everything encrypted and is relatively easier to handle. Basically, in addition to today's L3 VPN or EVPN to manage the client routes, and everything's encrypted. But for this we call hybrid network, where you have some ports facing the private, some ports facing the internet, there are some additional challenges to be brought into. One part being that those ports facing the public network, their IP addresses can be assigned by the ISPs, depending on who you buy service from. Some some of those WAN ports can be dynamically assigned IP addresses. Some of those WAN ports can be using private, right? So those WAN ports need to be managed on demand, basically. So one part of the SD-WAN nodes is really the ephemeral property, meaning a node can be instantiated on the fly and being removed based on demand. So it is very important to have the protocols to be able to handle those WAN ports management. In some of the deployments today, some vendors are using NHRP and to manage the WAN port management, but they have to do some extensions. And so instead of using NHRP, we're advocating to using BGP, because all those CPEs already have to support BGP anyway. So with little extension to manage the WAN port, make it scale better. So the WAN port management is really about registering is public IP address, private IP addresses, facing the WAN interface, the uplink, not the private. For the client side, is we're using the same mechanism as today. So each CPEs need to register his ISP assigned IP addresses, his loopback addresses, and also the controller need to be able to manage the adjacency, because you could have one CPE here in Prague, you could have another CPE in another country. And so the controller has to be able to manage the adjacencies through the public network. Another property is the controller connection to the CPE actually is through the public network. So that's slightly different from today's private network, where your controller or rod reflector is connected to your PEs through the secure network. So for that purpose, for managing the WAN ports, we're introducing a new NRI to register for the CP to register to the controller. So coupled with this new NRI, we have this newly assigned SAFI, just coupled with just solely put for the purpose of managing those WAN ports. And so here is the new NRI structure. We define the SD-WAN type. We define the port ID. We also define the site ID. Site ID is really a property shared by a set of SD-WAN nodes, because you could have a set of SD-WAN nodes sharing a common property. The property could be regulatory purpose, could be having some common location, geolocation, some traffic has to go through. And then you have the node ID, which can be IPv4 or IPv6 addresses. So for the SD-WAN nodes, since they can be far apart and in different locations through connected by the public network, it is depending on the controller, in this case, the RR, to manage the peering group. So that, say here, I just use example, one CP in Dallas, one CP in Beijing, and they actually belong to one group. Another group maybe is in different locations. So all those WAN port address propagation is policed by the BGPR. And then for the port itself, like when you want to register your port properties, the WAN port properties, you will have your address, your private address. If you use NAT, what kind of NAT do you use? What kind of, and your public address. So this is the extended port properties. So that's it. And if you have any questions, you can ask me. And we have, for general the SD-WAN, then we have discussion in the RTG working group.
Alice, I just see Cisco system. So we have another draft in the BIS, which we introduced last IETF. And we had a couple of offline meetings going through the different use cases. And I was explaining how we can meet all these use cases with that draft.
Right.
So why do we need another way of doing the same thing?
Okay, so for the draft, we've been discussing is really about the client routes being propagated by the BGP, right? You're talking about how do we map
Linda,
the client.
that's the homogeneous SDN case.
No, we discussed both homogeneous as well as heterogeneous. And I was explaining how we can do both of them.
Okay, so here is
But
really.
if it is not clear, I mean, I can go over it again.
Okay. The reason for this is really for the WAN port management, because today when you have a CPE, you use CLI to manage all the ports. You configure the WAN ports, right? You configure what kind of interface you connect it to. But for the CPE itself, for the SD-WAN CPE, we're talking about zero-touch provisioning, the node being created by itself, right? And the WAN ports, they could have dynamic address, and those addresses need to be reported to the controller. So this is a totally different aspect from what we've been discussing. So
the common denominator, regardless of the WAN ports, whether it gets dynamically allocated or statically allocated, or whether it is from the public pool or private pool, basically we need to be able to allow for the multiple of such ports to be flexible, to have set up the different IPsec tunnels among them, and be able to map different traffic flows to the different IPsec tunnels. All these can be done.
Time, we've hit the time limit, so we're going to cut the line. Sorry, after Ali. And Ali, I suggest that you and Linda should provide this discussion in writing on the mail list.
We have.
And I like to also request to be fully articulated what aspects of these use cases cannot be fulfilled with the other drafts.
I think my point is you should have the discussion
we will
on the email list, and you should both provide your points of yes or no. Okay?
Okay, so
folks
can discuss, continue on Wednesday, right?
Yeah. So please continue this interesting debate on the list. I really, on not just best list, on IDR list, since it's a proposal. Guys, if we're having side conversations, I'm going to pull it. Ali, please stop. Stop. It's impolite to Jacob, okay?
Yeah. Okay, hello. I got a simple one this time. Maybe we'll take a bit less time. Diagnostic path attribute. Page 2, please. Okay, here we go. My turn. No. a path attribute to assist with network troubleshooting. I think this one is probably better, more for vendors than for operators, but operators also. You can attach it to an update message, update it, and also attach it to a withdraw message. So I have a checksum and a timestamp in it. This is, all right, here we go. It's consistent of elements. As a prefix gets propagated from one router to the next, each router will add its element, and its element will consist of a number of TLVs, either and a checksum and a timestamp. The element also identifies the speaker with its ASN and router ID. There we go. Timestamp and a checksum. So I had another update. I added different timestamps for different portions of within the router itself, when it's received, when it's sent off to update generation, when it's sent to replicate to the right queue, so forth. All right, no unintended propagation. So the point of this is that it doesn't go and pollute the internet. So it's non-transitive, so those that don't recognize it will not send it. For those that do recognize it, we need a configuration to make it propagate. Now, I had a question from someone else. Should we propagate by default within an AS, right, if implemented? That's it.
So from kind of implementer perspective, I understand what you would do it. However, your draft completely lacks motivation. It only says do this, and this. I think it would greatly benefit if you explain why would you do this. It introduces additional complexity in new code and stuff.
Yeah. Why do I want this? Because I've had bugs. Right? in actually two different implementations of BGP that I've worked at. Had two different bugs that could have been solved much easier if I had a checksum that was being implemented during various stages within BGP. So the one I did took me longer to figure out, but it would have been easier this way. Timestamp, yeah, when you've got queues within your process, you can see, oh, the queue's really, really long, because one timestamp to the next timestamp, you can figure out if you've got multiple routers, between which router it's the delay. You can find routing loops, because each of the routers in the oscillation, each router will put its bit in there, and then it's kind of like an AS path, but a router path. Yeah.
So Jeff has, this idea has popped up before, at least for the timestamp piece. Stefan Kager and myself did a draft 3 years back, I think, IDR timestamp, if you want to go dig for it. So idea we thought was good. We ran into not only the problems that you're talking about here, in terms of, like incremental deployments. It does ugly things to state compression, because you have timestamps sort of colliding at the same router, and you have to pick one of them, and you're no longer able to compress the routes quite as well. So the idea is not bad, but it does have a lot of interesting fallouts, and that sort of motivated us at the time to say this might not actually be worth pursuing. Happy to talk to you about what we figured out. Could you go a little bit more into the checksum thing, because that one seems a little weird to me.
Okay, I'm aware of that and a couple of others, and I apologize for not mentioning previous work on this. And yeah, I'm aware of the breaking the update packing and the optimizations. And so this is why I put it in just no unintended propagation. You turn it on when you need it, and you don't turn it on for normally. So normally it won't do any harm. When you do need it, then you do need to be mindful of the breaking of the update packing. That sometimes is a problem. It's not always a problem, but you need to be mindful of it when you use this. Now, which is fine, right? But this gives you information that you may not have otherwise, and so it just makes it.
I'm not challenging the idea.
Yeah.
We thought the idea was a good one, and we actually discussed that in some cases. Probe packets, picking a prefix that isn't used for forwarding, may be a good way to avoid some of these issues. So again, like I said, I'm not challenging the idea, just that we ran into enough of the issues when we did this last round that we decided to stop. Interesting to see how we solve some of it. But again, the thing I was asking about past that was the checksum. I don't understand that specific use case.
Okay, I've had bugs where I actually implemented a TCP in a previous company, and I had this bug. Okay.
Okay, so
it was my bug.
Would it be fair to say that the case that this is probably more apt for is when the BGP stack may also be tightly coupled to the TCP stack?
Yeah.
Okay, that makes more sense. Thank you.
Yeah. Yeah, I know there's a checksum in TCP. So if you have it between routers, the TCP checksum will already catch it. But this is so for where BGP interfaces with TCP, or when TCP is sending something to the standby and you get segmentation reassembly going on inside the box. So this is more. So the checksum part is really more for vendors than for operators to find bugs. And your suggestion of using some kind of unknown or unimplemented prefix, so that doesn't happen to every prefix, that's a good one, and I'll add it into the draft.
Robin Huawei, can go to the previous slides, the page 4. Yeah, here I'm a little confused. Maybe I missed something. So here there's to record the timestamp for the various processing stage. I'm not sure this means this is the local processing or the, because from my point of view, if the local processing stage, why this information should be propagated? And another question is because this is a diagnose the information. Why you need the BGP? Why not use the BMP to collect this information for the monitoring or diagnosis? That's
okay. I've got the BMP. So there are multiple tools in which so that you can do this. Streaming telemetry and BMP are all tools you can use. My response to that is the more tools you got, the better. The more chance you have. So your other question, why should this be propagated? It's useful to propagate at one hop. The next one, you may take it out, you may leave it in. It's up to him. So now you can see the propagation between routers and within different stages within the router as well. That gives you information. Again, you don't normally turn this on. You turn this on when you have a problem, and you can find your problem.
Kevin Patel, Arcus. Queue buildups typically are very transient. So it'd be interesting, or at least if you have a justification to what Jeff said earlier, if you have a use cases that are laid out in the draft, that would be nice as to when to inject this, when not to inject this, because it's really hard to figure out queue buildups, and by the time you get to it, probably the problem is gone. And the second thing is what Robin said. If you were to do something like this, if you can outline how this is way better than the existing solutions like BMP, it'd be great also.
I'm not sure I need to do that. It's good enough as it is. So, I mean, you're free to implement it on it or not implement it. I think if you do implement it, you've got a leg up.
So the one place that came up in the prior versions of this stuff that we discussed is that sure, seeing when it pops out on the wire is a useful thing. BMP can give you that. Part of the motivation is, where do you do the timestamping? Do you do it before? Do you do it after? This was the thing that we discussed, because part of what you're tracing in some of these cases is the flow of where things are passing through individual pieces of the BGP pipeline across many routers. So being able to see that on receipt, you got it at timestamp X, on export, you did it at timestamp Y. That gives you an idea that there's inter-system latency of some sort within a box, and you can't cleanly get that sometimes from just BMP data. So there is motivation for something just beyond BMP.
Yeah, thanks. Okay, so various stages would be when you receive it from TCP, when you add it into the table, when you import it into the WRF, when you send it to RIB, when you start the update generation, when you do the replication, and finally send it to TCP. Different implementations have different stages, and so I didn't want to get specific about standardizing each of the stage because everybody's all different. So you put your own numbers in for whatever you want.
This sounds like a great thing to continue over a beer. Thank you for an interesting talk. And I think we'll ask for Srihari to come up. Thanks.
Oh, yeah. Working group adoption.
Jacob, do you want to circle and ask that in a day after talking to folks, or do you want to ask for working group adoption now? I just want to make sure. Okay.
Cut to the chase.
Cut to the chase. Okay.
All right. It's fine. Let me go through what this draft is all about. The inter-AS TE extensions for the BGP-LS to support the EPE. Basically, we saw the draft which talks about what if there's IGP, and this draft is not about IGP. This draft is about what if you're doing BGP EPE and BGP-LS extensions to do that for inter-AS specifically. Just as a background, there are these two drafts, specifically the one that's routing EPE, which I believe it's refreshed to 18. It describes the mechanism to carry the BGP peering segments in BGP-LS. And it also refers to 7752 with a lot of link attributes, codes, and things like that. But what I saw is, what we've seen is there are some gaps for specifically to support inter-AS multi-hop eBGP for TE purposes. Okay, so let's look at this diagram. You can generalize this diagram to be having multiple eBGP sessions between two routers. One could be per address families, depending on what you want to configure. There could be multiple interfaces to that. And the key is, if it is under single administrative domain for these multiple ASs, then the thing that we are missing in this is there is no mechanism to show is any link used for FRR protection. If it is, how am I communicating in the SID? So what we are proposing is there are multiple flags, VLBP, but we are introducing a F bit which says this particular SID is being used for FRR. So that way, when there is a failure, we know the traffic is going through that, and therefore the consumer, the application consumer, can figure out that that particular link is being used, especially with the inter-AS.
May I ask a question at this point?
Sure.
Having reviewed your previous draft on this that talks about the inter-AS, was it unknown that fast reroute was going to be a problem when you wrote the first set of segment routing information? Was it discovered in deployment, or was this just always planned as a second phase?
This was discovered during the deployment.
It was discovered in deployment.
Customer engagement.
Okay. Because I remember some comments from Alvaro, or maybe it was just in this general area. Maybe he's running to the mic.
I'm not running to the mic. I'm just standing here. Alvaro, so I've been reading that other draft right now because it's in my queue. And I think that other bit B says that means that the prefix is eligible for backup.
Yes.
And so what you're saying is that F tells me which link I could use for the backup. Okay. So so the question that I have is that when I did my review of the EPE draft, I asked the authors of that draft.
Mhm.
So, okay, what the heck do you do with the B bit? because, okay, it's eligible for backup, but so what, right? And the answer that I got back was that it's implementation specific. Somehow you figure out the other link, and somehow and you know, I don't have a problem with that because the draft already made it to the working group, and apparently all of you read it, and you guys also read it, and you agreed that it was implementation specific. Now, what you're saying here is that I am actually signaling what the backup could be. So that means that there's some contradiction
between the two things.
Between the two drafts.
Yeah.
So I'm not saying that you shouldn't progress this draft. What I'm saying is that the working group should think about this because I can't say that signaling for backup eligibility is implementation specific and that we're not going to specify what to do and then we're going to specify what to do, right? So either we specify it or we don't. And because that draft is still not published, then we still have a lot of time to discuss that here. I mean, it's great that you brought this up now, so that the working group can decide, can talk about that.
And
now.
targeting off of Alvaro's, you know, he and I probably wondered about the same thing as it, as how it would actually work in an implementation. I couldn't quite imagine, but I'm not an implementer of SR. If this is really something you've discovered in implementation, it might be something that gives more meat and substance to that particular section. So I'm thrilled to see this draft. I'm asking like Alvaro did, so how do I put it with the other draft? And maybe it's worth a conversation with the authors, and then maybe I'd like you to explain it to the working group here, because we might have to go back. Would that be a good ask? Okay.
Would it be
Thank you.
appropriate to hear the rest of that?
Pardon?
I said, but shall we continue the rest of
Yes,
the conversation?
thank you.
I mean, Ketan, is this appropriate for right now, or can we wait until the end of the presentation? I mean, up to you. Follow up to Alvaro, go ahead.
Yeah, I just wanted to follow up to Alvaro. So the B bit, what I think I replied to the review was implementation specific is how the node determines what would be a backup link that could be used for FRR. And since we are talking BGP here, really what's my other peering to the same AS, or how can I reach there in a loop-free manner, and all of those considerations are not really something that has been specified or covered by things like LFA, FRR that we have. So that point is a local decision. It could be really provisioned by the operator who knows how the peerings are done. And as such, that backup is thing. So all that the B bit is saying that this is protected by FRR. And that's about it. It doesn't really, we don't have this thing where it tells which one is serving as a backup, and neither do we advertise that in IGPs today. So just wanted to.
Okay. I'm sorry I interrupted your time.
Sure. Yeah. We'll take it up and then sort of between B and F bit. Yeah. The second problem that we saw is, again, in the same scenario, you can assume multiple eBGP sessions, multiple links between the two routers. In this, when we are doing eBGP multi-hop, for you to be able to really say that, how do we make this work from a centralized consumer, right? The local remote BGP peering addresses are not sufficient to identify. Today, as such, the drafts and the RFC that I mentioned before do not clearly convey how a eBGP multi-hop peering is possible. So what we are proposing is this. Peer said it must be advertised for inter-AS links, and it should contain the T attributes, local and remote interface addresses.
Can you guys hear okay, by the way?
Okay, all right. Is it better? Okay, cool. So let me repeat. So what we are proposing is peer said must be advertised for the inter-AS links, and it should contain the T attributes, local and remote interface addresses. And peer node said should contain the local IP address. Now, the reason why this is needed is because when the link fails, the consumer can then correlate which of the links are connected to the session, because it's a multi-hop session, which of this is connected to the session, and therefore take the appropriate action. Now, in all of this, we are definitely caveating unnumbered interfaces, because this is typically not used for inter-AS. So except that, this should work for multi-hop eBGP sessions for inter-AS scenario. Questions? Yeah.
Ketan Talalikar, Cisco. So we discussed this offline, and I agree that this is addressing a gap which has been there. That is ability to correlate links with the peer adjacency SID with the link for the BGP peer node SID, which is actually the BGP. So,
yep.
Yes, for the peering session.
No more questions?
Any others? Or
Just a very quick question. I was trying to read really quick the spring draft on EPE. Are you presenting this in spring?
This time not.
Okay. So the only reason I'm asking is because if I remember correctly, and I read that draft a very long time ago, the main case that it talked about was the case where the other draft is addressing, right? The one where you only advertise internally those external links, not this one. Now that's not a problem, but it may be that the spring working group wants to describe this as well. That draft already passed IAG evaluation, all that stuff, but it's sitting waiting for something else that hasn't gotten to the IAG yet. So if we're adding a couple paragraphs, that shouldn't be a big deal. So it might be a good idea to maybe, if you are presenting, sending an email to the spring working group, just mentioning that you're addressing this use case
sure.
that wasn't covered by the other BGPLS draft, and it may not be described in the spring document.
Sure, I'll do that. Cool.
Thank you.
Thank you.
This should be a simple draft. Can you guys hear me? Can you guys hear me?
Yes, better. You can adjust the height if you need.
All right. Before.
Wait a minute. I need to do this thing. What's going on? There's like too many things to click to make these Chromebooks work. Go.
Okay. So we have presented this document before IETF100. We presented the first version of it. Presented the IETF101, the version 3. With this one, we are presenting some major updates to the document after the lot of discussion internally and implementation. We are aligning this with the IGPs, which is actually makes the implementation simpler. Also, we are, I think the implementation is matured enough, and also the relevant documents are mature enough. For example, the SRv6 architecture, which is the network programming document, is in the working group adoption call. And also the SRv6 EP extensions is also matured. SRv6 also as a technology has matured over time. We have seen the deployment of SRv6. So this document is complementary to the things which are going on with SRv6 and would help with the overall deployment for SRv6. All right, at a high level, we have node attributes and we have link attributes. With node attributes, we're creating a new TLV to determine the capability of the node, whether the node actually understands SRv6 or not, and also an OAM capability. I'll talk about it. The MSD type, which you guys have seen before for SRMPLS, similar type has been introduced for, we're leveraging the same one, which is already there. But we are advertising with SRv6, and the algorithm support. So what kind of algorithm is being used? With link attributes, again, the same index and the IGP attributes and the LAN index. The details are in the document. And also a new MSD type, which is right now is the same, using the same MSD TLV. With prefix attribute, we are doing the SRv6 locator. It's a new TLV, so I'll talk about that. There has been comments on the mailer about the size of the LS attribute and how it's doing it. So to help with that, we're actually introducing a new NLRI type for SRv6 SID. This will be used to basically learn the capabilities of all the SIDs which are there on that particular node, or even basically the my SID table on that particular device. It also enables the granular BGP updates, so we can split the updates into multiple BGP updates to reduce the churn for the nodal NLRI, which is defined in 7752. Also, the SID attributes, we are defining the endpoint function TLV and the EPE node TLV, which is already defined earlier also. So SRv6 capability, as it says, indicates the node is actually SRv6 capable or not. It's creating an O-bit, which tells whether it's capable for OAM. We're also leveraging the new MST types, which are already which are defined over here, which is basically the ones, and the node points are not assigned yet. And the algorithm TLV, which is basically defined in 7752, we are using it for both MPLS and for SRv6. With ligand attribute, we are creating n.x SID TLV. This should not come as a surprise to anybody. It's pretty much standard of what we have used before. Similar what we have used before. The LAN and X SID TLV is also, which is the same concept which we have used with MPLS. And this is the MST type, which is same as what I described earlier. The prefix attribute TLV, this is basically defining the locator and also the function, the metrics, and the associated algorithm for it. For example, you could have a flex algo associated, which is associated algorithm with that. And some of the flags, which is basically the down bit and the anycast. The NLRI, which I was describing, just to reduce the size of the node NLRI, we're describing a new SRv6 SID NLRI to carry the SRv6 SID information from that node. And corresponding descriptors are being defined, which will carry the information TLV. So there could be multiple sub TLVs carrying all the SIDs of that node and learning the capabilities which that node is capable of. And the SIDs associated with that. So, and then there is already a multi-topology identifier, which is defined in 7752. We're using that. All right, SID attributes. So we are defining the function and the algorithm for SRv6 SID. It's the same concept for the functions and algorithm which has been described before, so it's pretty straightforward. And the peer node SID, which is for the EPE, we had defining the peer SID and also the peer set SID. Same concept for the EPE document, which is going through the working group right now. All right, with that, as I said, it's pretty similar to the concepts which we have used before for SR. We are just extending the same things for SRv6. And overall, the adoption of SRv6 as a technology has improved quite a bit. We even, as LinkedIn, and in some of the hyperscales, we are seeing the use cases for keeping it simple. I think the technology itself has seen the adoption. Some of the vendors have seen the implementation, and even some of the customers have deployed it. So I think with this SRv6 BGPLS extensions, it is only going to help to improve the overall adoption for the SRv6 technology. With that, I'm requesting the inputs, if there is any more, and also requesting the working group adoption.
So as part of the working group adoption, one of the things I mentioned to you I'd ask is, what were the improvements you found from the original specification maybe a year ago, year and a half ago, to the deployments? What did you learn in your deployments and in your initial implementations?
So one of the main things which we have learned is to basically sync it with IGP to keep the implementation simpler, so that we can reuse some of the code and the implementation which we have done. And that's one of the part of the reason which we have done here. Also to address the comments about the size of the BGPLS attribute is growing, we created a new TLV, the new NLRI, which will help.
Okay. And then how does just for the rest of the audience, what helps with creating the new NLRI?
Well, with SRv6, you're actually going to be carrying a lot more information. So with node NLRI, which is already being used, I think by creating a separate NLRI, it helps with reducing the size of the node NLRI, which will carry.
Okay, and I think that's important. Alvaro, did you have some questions?
Yeah, I do. Alvaro Rotana, Huawei, speaking as an individual. So I didn't read the draft, but I noticed in there that you said that you're defining a new MSD type in this draft.
No, we're not defining new MSD. It's the MSD type, which is already, well, actually there is a, let me go back to that slide.
I mean, maybe I didn't understand correctly.
Yeah, so it's basically the same concept which is there for the MSD. We are using, it's for the functions which we need for segment routing V6 to work.
No, I understand that.
Yeah,
My
yeah.
question is, you said that the values are not assigned. Are you defining the registry and everything else here? Or is that coming from the IGP drafts? Okay, good. That's all I wanted to know. Thanks.
So, Alvaro, what
The
was the
registry
answer?
has been already created for SRM PLS draft, so
Right.
I assume at some point you'll request.
Yes. Okay, let me go back.
Okay.
All right. Any other questions?
Yeah, Jadon from Huawei. You said that this design is aligned with the IGP ISIS SRv6.
The TLVs are.
Yeah, but I see that in the IGP you have the locator TLV as a top TLV, then you have the seed sub TLVs, right? But here you have the locator in the prefix NRI, then you define a new NRI for the seeds. Why you make this kind of change for BGP? Yeah,
I have an expert behind you. He'll answer that.
Yeah. So the IGPs, in the IGPs, we have a very limited amount of SID that's advertised, which is basically the end SID, and there can be a few of them. Whereas in BGPLS, we could have many more SIDs. And it again goes back to the, if all of these SIDs, SRv6 SIDs were advertised as a node attribute and locator in the same way, then we would really grow the BGPLS. Message size. So this enables more granularity, and as we see further, we'll have other types of SRv6 SIDs which are not being propagated within the IGPs, but maybe introduced in BGPLS. So that's where this granular signaling approach has been adopted. With this mechanism, you will have a individual update message for each SRv6 seed. Is that correct?
Not individual. You can pack multiple SIDs into the same SID.
Only if they have the same attributes, right?
If they have the same attributes? Yeah. So
If
you
they don't
do
have
the
the same
same
attributes,
level
you
of
have
attribute matching which you do today with BGP.
More updates message.
Right.
Right.
I don't think that's a concern. Okay, so with that, I request Chair for the working group adoption call for this document.
Glad to hear that. Thank you.
Thank you.
I'm teasing him because I've been bugging him to ask for working group adoption for a while. It's the first time I've had to pull a working group adoption from someone.
So just to introduce Ketan's talk briefly, this is slightly unusual in that the draft was, I think, finally uploaded like 6 hours ago. So normally we try to avoid having talks that, you haven't had a chance to read the draft. This seemed like it was interesting enough to the group, and we have a second session later this week, which we will have some time available for follow-up discussion during that session. So, if you hear the talk today to give you an overview, hopefully that will give you enough of a taste to make you interested to go back and read the draft, and then we can have a follow-up discussion on Thursday with people who've read the draft. So, and I'd like to thank, everybody involved for being flexible about scheduling and so on.
Thanks, John. Hello? Am I audible? Yeah. So we'll start off with why.
Well, can everyone hear Ketan? Yeah, okay, good.
Okay. So the question we start with is why do we need this update? So there are a few aspects that we'll try to go over. There have been a lot of questions and discussions on the mailing list about BGPLS carrying the information in BGP and the kind of checking, handling, error handling, semantic checking, and all of that that's needed to be done. So to set the context, one of the first things in the update is introduction of some terminologies, which we hope will help describe the role of the BGP implementation and what needs to be done as BGP-LS information is propagated. In that context, there are updates to the error handling and fault management aspects. So this is also a topic which has been discussed on the mailing list with a lot of inputs and clarifications on those. So this is to document that and review it. Then there is one aspect of BGP-LS, I think, which has probably not been discussed on the mailing list, but amongst some implementers that we've had discussions, there has been this, I would say, somewhat confusion or lack of clarity or ambiguity about of the use of instance ID in BGP-LS and how the IGP domains are actually mapped in BGP-LS. So we'll talk about that in a bit. Few other things, key things is those BGP-LS attribute, and as we keep adding more and more TLVs and extensions, there is a concern that we would hit the 4K BGP update limit. So we'll talk a bit about that. At this point, we don't really practically see us there, but potentially this is definitely possible. So it's better to address it upfront. And then there are some other minor editorial changes and introduction of some private use TLVs. So to start off and set the context, we've updated the diagram in the draft a little bit and introducing these roles. So the first one is the BGP-LS producer. Now this is a node as a BGP speaker which originates or introduces information into BGP-LS. I mean, it could be coming from the IGPs, it could be the nodes, local properties, all of that. So it's really originating information. Then we have a BGP-LS consumer. It's shown by the consumer block. Now this is actually an application or a process or a controller or any of those things that is actually using the BGP-LS information as information signaled via BGP-LS to do some functionality. The functionality would be application specific in that. Now technically this is we'd like to kind of separate it, so it's not really the BGP speaker or the BGP implementation. There is a kind of fine line that we probably need to draw there because this consumer application is beyond the scope of BGP-LS. So that's one of the key aspects. And then we have what we're calling as a BGP-LS propagator. So this is really a BGP implementation that is handling the BGP update messages with link state information in it, performing best path calculation, and it's really just exchanging or transporting the BGP-LS information kind of opaquely. In this picture, when we have this deployment with route reflectors or information going across multiple AS, we would have really something like a BGP route reflector, this RRM, which is really simply propagating the information, right? But the propagator piece, these roles are not really mutually exclusive. So the same BGP implementation can actually be originating information into BGP LS. It could be propagating certain other information and maybe also handing off some of this to a consumer application, right? So the definition of these roles are being defined just to help clarify where needed in the rest of the document. Next, we come to the link state NLRIs, and RFC 7752 has defined 3 types, but we have more being introduced by other drafts. Some of them are working group documents, some of them are waiting for adoption. But what needs clarification is that implementations must handle unknown NLRI types in an opaque manner. So they should be able to process and propagate these. I mean, this is what we would enable us to introduce new extension without requiring upgrade of the BGP infrastructure. And I mean, example is a route reflector. The capability negotiation is done at at the FE-SAFE level, but not for individual NLRI types. But this is something which we thought would help getting clarified in the spec so that implementations handle this well. Now, within the NLRIs, we have a bunch of TLVs that can be used. They are called descriptors, so node descriptor, prefix, link descriptors, and other types. So the proposal or already the text in RFC 7752 does indicate that we need to handle it unknown, unsupported TLVs in there. But what's we are adding is that we don't require BGP speakers or BGP implementation to do semantic validation on what's really in the TLV values and fields. So obviously we need to do the syntactic validation so that lengths and all of those informations are proper, so we can parse and process the BGP messages, but not really go into the semantics. And this is because as more and more, again, TLVs and information gets added, we don't want to bring in a lot of these new complexities or things into the base BGP implementation. Like, just think about from a BGP-LS propagator point of view. The only rule which is there, and it comes in the existing RFC 7752, is that the TLVs types in the NLRI are organized in ascending order. And this is required so that we do not have multiple instances of the same information appearing as different NLRIs in the BGP tables just because somebody is arranging it in any order. So this is just mainly to help that. And if not, then trying to clarify that it could be considered as a malformed NLRI in that case. Now, the syntactic checking is done by the BGP implementation, but the semantic checks are proposed to be done only by the actual consumer application. So that would be outside the scope of BGP-LS. Next, we talk about the BGP-LS attributes, and even within this, the TLVs are proposed to be handled opaquely. I mean, this is already existing thing which is there. We're just trying to clarify this in the document. Here, there is no need for ordering by TLV type. Any of those limitations are there. And any unknown, unsupported, even unexpected TLVs should be handled opaquely. Now, as more and more information is added in here in BGP-LS, it's possible at some point we will have so much in the BGP-LS attribute that we could not fit it in a single BGP, BGP update message for a single NLRI. Yeah. Okay.
Could we just take it at the end of the slide?
Unless it's clarifying for this slide.
Yeah, unless it's is it a clarifying for this slide?
Yeah, I just wanted, Kair Patel, Arcus, I just wanted to let you know that if you drop it and consider it as an attribute discard in this case, it's quite possible that the consumer may not have a clear picture of the network topology, and you may want to signal that somehow.
I'll come to that. So,
Thank you for the clarification here. That's important.
Yeah. So, so I didn't put that on the slides, but it's there in the draft. So there are few ways to go about it. One is BGP extended messages, but we know it will probably take time to really get it deployed and rolled out. One other option is that a producer can have, or implementation can provide a limit at a producer where the number of TLVs or what's put in there is limited. And then, again, it's applications dependent on what TLVs are important or not important, but we let the producer decide on that, right? Now, it's possible that we have done that, but still the update message grows as it's propagated. Let's say, AS path is added or some other thing. So here we're talking about attribute discard, but we'll come to it in the fault management. To answer Kayu's question, the proposal is when we discard the attribute, we still propagate the actual link state NLRI all the way to the consumer. So when a consumer sees a link state NLRI without any attribute in it, that's kind of like, say, a hint that this information is not withdrawn, it's still there because the other BGP attributes are still there. And then that may be used to kind of debug or troubleshoot at what point in the BGP propagation was this discarded. I don't know if that answers the question, but yeah.
So the question that it begs is, do you get into a loop where the consumer doesn't know what the topology is, so you have problems and you're not getting the right error feedback, so the error continues? You don't have to answer now, you can do later.
Right, this seems like great fodder for either a mailing list conversation or follow up on Thursday.
Okay, yeah, we can. So here the semantic checks are again for the consumer, not within the BGPLS scope. Next is instance identification in BGPLS. So we have multi-domain IGP topologies, which are link state objects from here are advertised out via BGPLS. So a consumer sitting on top can really have a clear multi-domain topology view of the network. Now, in order to do so, we have something like, we have a 64-bit identifier in the NLRI, and this is called the BGPLS instance identifier. So this can be, is applicable both for multiple IGP domains. So let's say multiple routing processes on the same node, but also can be used for multi-instance where we have multiple instances of the same IGP running on a single link. So this identifier is configured at a IGP instance level on the producers. That's the node which is originating the information. And when we have multiple BGPLS producers advertising topology information from the same IGP domain, we need to ensure that the same identifier value is configured on the other producers in that IGP domain. Plus, when there are multiple domains, we need to give a unique identifier to the other domains. So these things are what would help really somebody who's looking at this BGPLS information like a consumer to really construct or identify or correlate the link state information coming to it to the actual IGP domains in the network. Right? And we have another TLV 513, which is called a BGPLS identifier. And there has been some confusion whether this is the instance identifier that we talked about, or whether it is a 64-bit identifier which is doing that function. And I would really look for feedback from implementers on what they have done. Based on offline discussions, this is what would like to propose, but we need to really discuss and see how to handle this. Plus the backward compatible aspects, if there are, based on the implementations out there. Next is the fault management. Again, as an overview, so BGPLS provides transport for link state in an opaque manner, and this is what we kind of want to re-emphasize here. So syntactic checking only is what we expect BGP to do, not really semantic checking. at all. And it's the consumer of the BGP-LS information which would do the semantic checking, right, and interpretation of TLVs, fields, and all that. Now, it's possible that there are errors in the TLVs, but handling of those errors would be done actually by the consumer. And what kind of handling is done by the consumer is very much application specific. It's not something that we can generalize or hope to cover for all applications that are there today or maybe developed in the future. So we keep that outside the scope of BGP-LS here. So specific to link state NLRIs. Now, when the error in the link state NLRI or the TLVs in there is such that we cannot really parse or process the message, then we have really not much option but to do something like a session reset, right? Or in case where it's possible and supported, when we don't have session isolation, we can do a AFI disable. So these are just recommendations. Things would also depend on the implementation aspect, right? Now, when the error is affecting a specific NLRI, or let's say all the link state NLRIs in that update message, then but we can really identify, we don't have a problem in parsing or processing the message, then we can treat as withdraw, right, or ignore this thing. Similarly, for the BGP-LS attribute, it's somewhat similar on when we need to do something like a session reset or AFI disable, and when the error is within the BGP-LS attribute itself. So some TLV within it doesn't have the correct length or so, but the BGP-LS attribute length, for example, is fine. I mean, so it can be read. Then we would it's the attribute discard, which is there in the existing RFC 7752. That's a recommended. But here we're looking for the actual NLRI, link state NLRI, to continue to propagate without the BGP-LS attribute, so that the consumer does not misinterpret this as that link state object. Let's say a node is going out of the network. So it still sees that object in the network, but it doesn't have information about it, right? And the idea there is that it probably enables some sort of a diagnostic to go and look back and figure out where this problem happened. One other clarification, I mean, it might be obvious, but need to clarify, is that when we say BGP-LS attribute discarded, it's not for individual TLVs, but the entire attribute is getting discarded. I mean, there might be some kind of ambiguity in there sometimes. So on the fault management and error handling, obviously appreciate feedback, discussions offline or on the mailing list. Next, so this is about, it's not something which has been discussed on the mailing list, but based on implementation and deployment feedback, I want to run through this example. And it's about handling of unreachable IGP nodes in a network. So let's take this picture here, and let's say it's running OSPF as the IGP, and we have this link between R2 and R3 in area 0, and all the other links are in area 1. And we have R2 and R3 as the BGP-LS producers who are advertising the information. So they would do it for both area 0 and area 1 to BGP RR, R0, which is then passing it on, let's say, to a consumer. So consider the scenario where the link between R5 and R6 goes down. Now, this is a link state IGP, but what happens is that on, let's say, look at R2, on the on R2 in the link state LSDB of R2, it still continues to hold the router LSA of R6. Now, in this router LSA of R6, the link from R6 to R5 is still present in that router LSA. Because here, if you see, when the link is broken, the area 1 is getting partitioned into 2 parts, right? So R2 still has the router LSA of R6, which is kind of stale, but that contains the link from R6 to R5. Whereas since R5 is still connected to R2, R2 receives the updated router LSA from R5, which does not have the link from R5 to R6 anymore. Okay. So, and the converse happens in the case of R3. Now, if R2 were to just advertise everything that was in the LSDB on its IGP node, then what would happen is that R2 will advertise the half link link NLRI from R6 to R5, which is it gets from the stale router LSA of R6, and R3 does the reverse. Now, when these updates go on to the BGP route reflector R0, these are actually 2 different NLRIs, and they would just go through to the consumer. There is no nothing in the BGP update processing which will select or one over the other. So when it goes to a consumer actually sees a complete link because it has 2 half links. It sees that R5 and R6 are connected to each other. So it does not really get a true picture of the underlying network topology. A different aspect of it is even let's say the R3 is based on the BGP best path processing, R3 is the preferred node. So what happens is for all the nodes R1, R5, R6 and R4, the link state objects are being advertised by both R2 and R3. And let's say that in the same broken link case, R3 is really the preferred source by R0. Maybe the next hop is, it's a better next hop. So what happens is R3 is giving stale information about R5 and R1 in this broken link scenario or this partition scenario. But R0, because it's just running BGP best path, doesn't have the knowledge of what's newer, what's stale. So it would actually end up sending the stale information about, let's say, R1 and R5 to the consumer. So the solution for this is that much like how it's done in the IGPs, that the node BGPLS producer, which is distributing information into BGP, withdraws information pertaining to nodes which are unreachable to it in the IGP. So IGPs do not use information or LSAs or LSPs from nodes which are unreachable. We're asking that the same be done when they are originating information into BGPLS. Now, this aspect has not been discussed or covered so far, at least not to my knowledge, but we would welcome feedbacks, inputs on this one. Right? The goal here is not to change the BGP processing, but still give the consumer the actual true topology picture. There are some other changes, more details are in the draft. So there was some ambiguity about MTID TLV, and it's clarified that it should or must be used when there is MT in the underlying topology. Some things related to OSPF route type needs to be mandatory TLV for the prefix NRIs because we can have multiple route types. Some new things which have come up like OSPF support for node name, this has been added. There is some clarification on session isolation for BGPLS that's there in the operational section, operational consideration section. And there is also introduction of this private use NLRI and TLV space for doing vendor specific extensions without conflicts. We have opaque attributes today in the draft, but their use and things are not really well clarified, I would say. So it's possible that there are implementation challenges on that. There are other changes as well, and when we've shared the update on the mailing list, it also includes a diff from RFC 7752, so you can check all the changes in there.
Kevin Patel, Arcus. Can you go back to the last slide? Yeah. My suggestion is to move some of these things into a different draft and not include as part of the BIS, because for the folks who have implementations, we would like to simply fix what is covered in the BIS and still be conformant to the RFC, as opposed to adding the newer set of information that's been proposed.
Sure, I think it will help if we can go over the details and see which parts make sense and how to do that.
So, just interrupt, sir. So I've read the diff only. Very good write-up, clarifies a lot of points that we've been discussing over the last 2 years. I noticed that you remove external type 2 SPF. Is there a reason?
I don't think it's removed.
In the diff, it is. It's missing.
Okay. No, I don't think that was an intention, or I will double check on that. But there's no intention to remove.
Well, that's a very good document and timely.
Okay, and the line is cut after Cengiz, and we have more time available on Thursday after you've had a chance to look at the draft.
Cengiz Alaaddinoğlu, Siena. Actually, we did have an implementation of BGPLS, and we find two specification bugs in OSPF. One is very basic, basically for the pseudonodes, the mask is missing. And the other one is very complicated. It has to do with the summary routes coming into an area, and then they have to route to write this unroutable. You're supposed to have a, I think, next hub field or something of that sort. That's also missing. I can get you the details and then.
Sure, I think we
there's
can.
two specification bugs. Which
Sure.
is
So any feedback, inputs on thing we can try to capture or cover in there. So yeah, I think we'll continue on Thursday.
Yeah, we will.
But offline as well.
Yep. So right. So now you can catch Kitan. Between now and Thursday. I volunteered you. You'll notice how I did that. Yeah, we'll continue on Thursday. Thank you, everybody. I checked, and on Thursday we do not have a crazy room with a giant column in the middle of it. So there's that. So see you all on Thursday. Oh, and if anybody hasn't blue sheeted, please blue sheet, because that's the reason we get these tiny rooms.
Thursday lunch.